Today we're going to be doing the 4.8 geometry quiz, and let's start. It's mostly about bearings. So we have from a lighthouse, so let's draw it. From a lighthouse, let's name it Lighthouse L. Ship A is at a distance of 6 radical 5 miles on a bearing of 40 degrees. So I want to draw first, and with another color, the north, for L. This isn't anything, but this is what we're going to use as our reference. This is the north. Now, ship A is at a distance on a bearing of 40 degrees. So, ship A, we're going to imagine this is 40 degrees here, and there is ship A. And this is 40. Now, at a distance, and it's at a distance of 6 radical 5. Now, ship B is at a distance of 12 miles on a bearing of 310. Now, if we started here, if you do one full turn and come back here, this would be 360 degrees. So, let's say you have this is your east, right? So this line would be 270 degrees. So 310 would be between 370 and 270 and 360, right? So let's say if this is 360, you need to subtract 50 degrees from it. Here, somewhere here would be 310. And between 310 and the 360 line, you have 50 degrees. And here is ship B at 12 miles. Now they want to know what is the distance between ship A and ship B. So they want to know what is this distance here. Now I want you to notice something. Your two angles were 50 and 40. What does that make when you add them up? 50 and 40 gives you a 90-degree angle. So this is a right triangle. If this is a right triangle and you need to find K and you have two of the sides, what do you have to do? You do A squared plus B squared equals C squared. So sides plus side squared equals hypotenuse squared. So 6 radical 5 squared plus 12 squared equals hypotenuse squared. Now I'm going to do it on my calculator. 6 radical 5, when you square it, is going to be, you have to add the brackets around the 6 radical 5, by the way, or you're going to get wrong answers. So 6 radical 5 is 180 plus 144 would give you 324. 324 is hypotenuse squared. So hypotenuse squared equals 324. So hypotenuse equals radical 324, which is equal to 18. And that is the length of K. And that's your first question. Now let's move on to the second. So for the second one, it's telling us you have a car travels from station X to station Y. So we have station X. You traveling from station X to station Y. Don't forget, it's always going to go from the north. You're always going to start. So we draw the north always. So starting at station X, it's going to go 460 meters away to station Y on a bearing of 210. Now, I'm just gonna continue the coordinate plane to make it easier for myself to explain. This is point X. 210 on a bearing of 210. Where is 210? This is 0, 90, 180, 270. So 210 would be somewhere between 180 and 270, right? From 270, it would be 60 degrees away. So somewhere here. And here would be 60 degrees. And this is your station Y. Now, a car will travel from station X to station Y, they want the distance due west that the car travels. So what you need to do here is you're gonna draw a perpendicular line from this to due west. So here, this angle is 60, and this, since this is always gonna be perpendicular, this is 90. So this is 60 and this is 90, then this is 30. You have a semi-equilateral triangle. Let me draw my angles with a different color because they're not really showing. 60, 30. Now, they want the distance that the car travels west from their starting point, which is station X. So they want this distance. And they told you that the distance from X to Y is 460 meters. Now, since this is a semi-equilateral triangle, what do we know about a semi-equilateral triangle? We know that the side opposite to 30, is half hypotenuse, and the side opposite to 60 is hypotenuse radical 3 over 2. Now, they're asking us for the side opposite to 30, the distance west. So it's half the hypotenuse, and the hypotenuse is the one opposite to the right angle. So half of 460 would be 230. And that is your answer. Now, let's move on to our next question. Okay, again, another lighthouse question. So we have from a lighthouse, here is your lighthouse. Ship A is at a distance of 20 miles on a bearing of 20 degrees, and ship B is at a distance of 20 miles on a bearing of 260 degrees. Now, ship A, let's draw it with green, is at a distance of 20 miles on a bearing of 20 degrees. So the bearing of 20 degrees would be somewhere like this. Here is ship A at 20 degrees, which is here, 20. Okay, that you can't really make it smaller. We're just gonna 20 degrees, and its length is equal to 20 meters. Now, ship B is at a distance of 20 miles, it doesn't matter, and on a bearing of 260. So we said this is our 270 line, this one, the west. So 260 would be right under it by a bit. So let me actually just draw it with blue so you understand. This is due west. So our ship B should be at somewhere like here, right before the 270 by 10 degrees. So like this. Here is 10 degrees. And it's at 20 miles. Here is ship B. They want the distance between the two ships. So they want this distance over here. Connect between ship B and ship A. So we know that this degree is 20 degrees and this is 10. And this is a whole quadrant, which is 90. So if we were to rewrite it, we would have, you know what, just forget the 20 and the 10 exist. We would have a 120 degrees, because 20 plus 10 is 30, plus 90 is 120 degrees, right? And we know that we have two sides, 20 meter and 20 meter, and one angle. If we did the last quiz, we would know that when you have two sides, one angle, and you want another side, we can use the cosine rule, which is side AB squared equals side 20 squared plus 20 squared, which is A squared and B squared, well, or side AL squared and side LB squared, minus 2 times 20 times 20 times cosine of your angle, which is 120. Once you put all of this in your calculator, let's see what we get. You get 20 squared plus 20 squared minus 2 times 20 times 20 times cosine of 120. You get AB squared equals 1200. They're asking you what's the distance, though they want AB. What you do is you put that in your calculator. Radical of AB of 1200, you get 20 radical 3. They gave you the radical 3, you put the 20. And that is it. Now, moving on to question 4. Okay, so for question 4, they're telling us you have, what's it called? The angle of elevation of a vertical tower T from ship S is 17 degrees. So what we need to do is we need to draw it out. So you have your ship, you have your tower T. Your tower is going to be standing, so T here. We know that T is higher than ship S because it's vertical tower and it's at an elevation. So from ship S, okay, we know that here the angle is 17 degrees and the ship is sailing 400 meters due east of the tower. So the ship, this is the tower, and the point T is the top of the tower. So the ship is here and this is the tower. So the ship is at a distance of 400 meters from that tower. The tower is, I'm going to redraw the tower in blue. So point T is the top of the tower. And it's at an angle, like you have to look at an angle of 17 degrees to see it, the top. We need to know the height of the tower. So what is the height of the tower? It is this. How tall is the tower? So since this is 17 degrees and we have one of the sides, one of the angles and one of the sides, we need to find this side. How do we find this side? What angle do we use? Or we know this is a 90 degree angle, by the way, and that this is 73 because 90 minus 17 equals 73. Okay, so what do we use to find the short leg when you have the long leg? Tan of 17 equals sine opposite over adjacent. So the opposite is x, adjacent is 400. So once you do it on your calculator, which is, wait, to cancel it you need to multiply by, so which is tan 17, which they gave us as 0.31 times 400. Let me put it in my calculator. Wait, I think I did something wrong. Let me try though. No, it's equal to 124 meters. And that's it. So you always have to understand the question and draw it out correctly. Always draw it out to actually know how to answer. And that's it for this question. Now let's move on. Okay. So this question, it's telling us as a fraction in the lowest term, what is the tangent of the angle in the plane ADZY to the plane ABCD. So the plane AZDY, the thing they have shaded, to the plane ABCD. So practically what they're asking is what's the tangent of the angle between them. This is the angle between them, right? They want what's the tangent. They gave us that this side is, let me draw with another color. This side is 8, this side 17, and this side is 15. And this is the angle you need. So 8, 17, and 15. So tangent of A is opposite over adjacent. So 8 is the opposite and 15 is the adjacent, and that is it for your answer. It's not that hard, this question, especially since they gave you everything and they even shaded it in for you. Now let's move on to the next question. Okay, So for this question, they gave us a square pyramid and they're asking us different questions. So let's start question. Here they're asking us first question, find AN. Now this is AN, right? We know that AN is sitting on a triangle, AED. It is a angle bisector and it's a median. We know that side BC, this everything in red, all the sides in red here, other than AN, of course. Let's change AN's color. All the sides in red are equal to 10, and all the sides that I'm gonna draw now in green are equal to 13. All these sides are equal to 13 and all these sides are equal to 10. So green is 13, red is 10. Now they're asking us to find AN. We know that this is, the whole thing is 10, so half of it would be 5. And this is 13. And this, since it's a perpendicular bisector, it's a right angle. So this is a right triangle. So we need to do a hypotenuse squared minus side squared to give you side squared. Or you could memorize it's a 5, 12, 13 triangle. Whenever it's a right triangle and one of the sides is 5 and the hypotenuse is 13, the third side is always 12. So since the third side is 12, then AN would be 12. Since we found AN, now we need to find the area of AED. So AED. We know that the area of a triangle equals half base times height. So what's half is half, base is 10, and the height is what we just found, AN, 12. So half 10 times 12 is 60. So that's the first two parts of our question solved. Now let's move on to part C and D. And let's go. So they want the total surface area of the pyramid. So we need to first dissect the pyramid. What's the pyramid made out of? It's made out of one square and 4 of these triangles that we found the area of one of them. So 4 triangles, it's a pyramid. So since we found the area of one triangle and we have 4 of them, you do 4 times the area of 1 plus the area of the square. The square is side s squared, side squared equals the area of a squared. And we know one of the sides is 10, so 10 squared, which is 100. And you're gonna get 4 times 60 is 240, plus 100 is 340 degrees. That's the total surface area of the pyramid. First part A, B, and C are all things you could do with math we learned in the previous years. Now part D, it's asking us what's the cosine of the angle between the two planes AED and BAC. Now let's draw out what they're asking for. Let me erase everything here and let me draw it out. The cosine of the angle between the two planes AED, so this is A, E, D, and B, A, C. So wait, let me just see something. B, let me draw it with another color. B, A, C. They want the angle between these two triangles. So what they're practically asking you for is the angle between the two midpoints of these triangles. What they're asking you for is this angle. I think, wait. Yeah. So they're asking you for this triangle that we just drew. And we know that this triangle is made out of two of the ANs and side AN. So it's made out, let me redraw the triangle aside from the triangle. This is N, this is A, and this is the midpoint here, which I'm gonna call M. this side would be 12, and this side would be 12, and the length of the square would be 10. You want the cosine of the angle. What angle? Angle A, which is the angle between them. So how do you find that angle? Because look, you have two sides that are like, imagine it's a tent and you have two faces of the tent. You need to find this angle between them, and this angle you can only find it by finding the triangle A and M. Here's M. Okay, so the cosine of angle alpha, we need to find it. So we're gonna use the cosine rule because we have three sides and no angles. So cosine of alpha, or A, equals the two sides that make up that surround the angle, so the green sides. So 12 squared plus 12 squared minus the angle that doesn't have anything to do with the sides that make up the angle, so 10 squared, over 2 times 12 times 12. Now let me put all of it in my calculator and see what we get. So 12 squared plus 12 squared minus 10 squared. Again, always put brackets around the 10, so your calculator actually subtracts them and doesn't add them. Into 2, into 12, and 12. You're gonna get cosine of A equals 47 over 72, which is your answer. If they asked you for angle A, not the cosine of the angle, if they asked you for the actual angle, you do A equals cosine -1, which is shift cosine in your calculator, of 47 over 72, which in case they asked, which they didn't for this question, I'm just gonna do it really fast, is 49.2 for whatever. But they didn't ask, so we're gonna forget this step. In case they do in the exam, just do cosine negative of whatever this is. Now, on to our last question. The bearing of P from O is something degrees. Always you need to know how to read the question. The bearing of P from O. So O is your original point, and you want P from O. And like I said, you always start with the north. So this from this is this angle. And since one quadrant is 90 degrees and they gave you part of the quadrant, you do 90 minus 57 equals 33. And that is your final answer. That's your final answer. And hope you understood everything. Have a good day. Remember, for this chapter, draw everything and always have it visualized. If you don't draw it and if you don't have it in front of you like as a picture, you're most likely not gonna get the answers like fast. So yeah, have a good day. Bye.